Okay, I believe that we're live now. This is Valerie Robb, and welcome to the second BizTalk Migrator webcast that we've got. Today, we have Andrew Rivers and Dan Probert with us to talk about the BizTalk Migrator. And we're going to go through some of the repositories and how to get this working just locally so that you'd be able to make your own changes to the Migrator. And so with that, I'm going to turn it over to Andrew to present.
Hi everyone, I'm just going to share my presentation. Just bear with me one moment. Has that come through yet?
Yes, I see it. Okay,
so hi everyone, I'm Andrew. I'm going to talk about building and debugging the BizTalk Migrator. And a little after me, Dan is going to talk about a lot more about understanding how you can work with some of the actual content of it so that you can make your own changes. So last time on the last BizTalk Live, we talked a lot about design intent and what the thinking around it was. So based on conversations I've had with the team that designed the BizTalk Migrator, we talked a lot about how the tools put together and why, how the repositories then produce separate packages and how they plug together, how the conversion process works, and then Dan gave you a great walkthrough of the converted output and how that looks in Azure. So that's a great foundation for understanding the BizTalk Migrator. And this time, what we're going to do is we're going to look a bit more about building and debugging locally. And we're going to go through how the conversion process works in a bit more detail in terms of how it works technically. And that will allow you to make your own changes because this is an open source project. And the more of us that contribute, the more features of BizTalk we support, the more valuable it becomes for everyone. So that's really what we're trying to get to. So last time I showed kind of this diagram, which is all the different packages. So everything is prefixed with AIM, which stands for Azure Integration Migration. And we have 5 different repositories in GitHub. And these are and this is a summary of what they are. So we've got the command line interface, which is the AIM tool repository. And that's also where the developer, the documentation is. Then there's the core runner, AIM core, which is kind of the heart of the application. And then we've got everything that's BizTalk specific is in AIM BizTalk. Everything that represents an integration application in Azure is in the AIM model repo, and then the templates are in AIM Azure. And so you can go take a BizTalk app at one end and it goes through those bits of code, and output at the other side is your new and shiny app in Azure Integration Services. So that's kind of what we showed last time. What we really want to talk about now, because we're talking about building and going to look a little bit more at the dependencies. So each of those repositories builds a package, and in that package is obviously code. So we start off with AIM core. Like I just said, AIM core is the fundamental, is the heart of the application or the core of the application, hence the name, and that contains key interfaces, and it contains the core runner that makes everything actually run in the application. Now that is referenced by a lot of things. So that's almost like that's the thing that everything else pretty much references. Now AIM tool, which is the command line interface, is really the programmatic entry point into the task runner. So the task runner is the thing that actually runs all the different conversion stages that results in outputting an application you can deploy into Azure. Now, AIM tool kind of references or relies on the AIM BizTalk, because AIM BizTalk is where all the BizTalk conversion is, but it uses dynamic loading for that. So in other words, when we run the tool, we give it a folder to look in for assemblies, and it dynamically loads those assemblies. And given that those assemblies will have interfaces that, or the assemblies will have classes that implement interfaces that appear in AIM core, then AIM tool knows what to do with them and it will run them. Now, AIM BizTalk obviously gets its interfaces from AIM core, and one of the things we're doing is we're populating that model that represents the integration app in Azure. So there's an interface there which is iApplication model that implements. So AIM core really has got everything else pointing to it. Everything else is referencing AIM core, but the we don't see many dependencies between the different packages. Obviously, AIM BizTalk is relying on AIM model because it's populating that model. And then finally, we've got the AIM Azure project, and that's, again, it's not a direct reference, but it's pointed to via configuration, because in AIM BizTalk we have configuration in there that tells it what templates to use. Then AIM Azure contains the templates that we're going to convert into and produce the actual artifacts for deployment into Azure. So ARM templates, for example, are tokenized in AIM Azure as liquid templates, and then the data from the model gets combined with the template, and that produces our artifact for Azure. So really, in terms of how we're going to approach this, really, if what I recommend, if you want to build this locally, so getting ready to sort of run everything locally, first thing is to go to GitHub and fork each of the repos into your personal GitHub account. And so you can't make direct changes into the repos because they're in the Azure organization, but fork them so that when you make changes later, you can issue pull requests back. And then what you want to do is to clone the repos onto your local machine. So for that, you can use that with Visual. You can just clone them through Visual Studio, as long as you've got the Git plugin, or you can clone them using the Git command line. And then after that, open them all up, build them locally. So each of the solutions will load their references as NuGet packages, so you don't need to worry about having more than one solution open at the same time. But if you just do that, that will get everything built and ready on your local machine. And so if we want to then run that locally through Visual Studio, I mean, any of the solutions we want to change, you can actually debug into. But the one you'll have open in Visual Studio is the solution that you're particularly interested in, and most of the time that will be the AIM BizTalk solution, because that's got all the conversion from BizTalk to Azure, and it's got the rendering of the templates in it. So really, that almost all the code that you're going to want to actually debug is going to be in the AIM BizTalk solution. But your entry point is the executable aim.exe, which is in the AIM tool repo, and you need to run the command line with the debug option. And once you've run the command line with the debug option, you'll then be asked to attach Visual Studio onto that process, and away you can go debugging. So what I've got an example here, hopefully this is readable, because I know there's quite a lot in here, but I'm going to debug with an example command, and that is so we do aim and then the debug flag and then migrate. So migrate is telling it to run the migration process end to end. So remember we talked about a moment ago about the fact that the assemblies are dynamically loaded. So what we have is the -p switch is that we will look for any DLL that has stage runners in the name of it. So that's a pattern. So that's the find pattern. So we'll look for any assemblies that match that pattern. The -f flag is the folder in which we're going to look for those assemblies. So in this case, it's my local GitHub repos, and it's then pointing into the bin folder where I've just built that solution into Visual Studio. And then we've got a couple of specific package-specific things. So we're pointing at the MSI file to do a conversion, which is in this case, it's the FTP pass-through. I think that's what we did on the last Logic Apps Live to just run a conversion. And then we've got another switch, which is where we're going to unpack the MSI into, because as you know, an MSI is just ultimately an MSI is like a zip file that contains cab files, which are zip files. So we unzip a load of zip files and then we unzip those again, and that gives us access to the assemblies that BizTalk application will have, and it gives us access to the binding file, and it gives us access to the application definition file, and it gives us access to any web applications that are being exported as part of that BizTalk app. So and those get unpacked onto the hard drive. So that's just setting the directory for that. I'm also setting so the -w is the working directory, so that is where any files will be created. The -s switch tells us where it will write the state to. So you can see I'm just putting this all in the same place, but the state is so we talked about that model, that we're building up the model as we go through. So what we can do is we can actually output that model as a big JSON document, and that is using this switch down here, which is the save state. And the save stage state means that as we go through each of the steps in the migrator, from discovering the BizTalk artifacts to parsing them, analyzing them, reporting, converting, we can save the state before and after each of those stages, so that we can see, exactly what we've got in terms of state. Now, what we haven't seen before, that's also useful for this debugging process, is we've got a -T switch, and that is the templates. So that data, that state, that model of an Azure app, combined with the templates, is what gives us our final output. So so if we want to actually change the templates, if there's a bug in them, or we want to make new templates, then we can point to a local folder that contains the templates, and they go in the AIM Azure repo. What I've done also in this case, I've given examples of the primary and secondary region, so that when we generate our BizTalk deployment scripts, it'll know what region to put them in. And then we can set a variable for the deployment environment. So if you want to tag your deployment, either production or dev or test, you can create a load of you can create your deployments that will be tagged as that environment. We then have a unique deployment ID, and that's there merely to stop namespace clashes, because things like API management or whatever, and anything, or storage accounts, anything that creates globally unique Azure artifacts, we just append a suffix onto that, which is your unique deployment ID, so that your artifacts aren't going to clash with someone else's. And then there's just another switch here. We've got no abort, and that means that the tool will continue to run, even if there's an error, it will continue. Leaving that off will mean that we fail deliberately, and we kind of have a hard failure, and we can assess from there what the cause of the failure is, whether it's something we've done or whether it's a bug in the tool. And then the final switch that I'm going to run is the -V, which is verbose, which means that as we run on the command line, that we're going to be verbose. We're going to put the maximum amount of content out into that command line, so we can see what's happening. And if you want, you can pipe that output into a file, so that so later on you can go back and you can see exactly what's run in the tool. So I'm now going to flip over onto a demo. So what I've got here is Visual Studio, and in Visual Studio I've got the AIM BizTalk solution. So I think, as we saw last time, these bits, the bits in the Solution Explorer may be slightly too small to read, but we have assemblies for all of the different stages of conversion. So we've got discover, parse, analyze, report, and convert. And so we have libraries for each of those. And then we have a stage runners library, which is the one that brings them all together and implements the actual interfaces that pulls them into the tool at runtime. So in this example, I'd like to debug. But what I want to do is I want to debug the real start of the process, where we look at what's in an MSI. And so if I go to the Discover library and go to the MSI Discoverer, I've got the code here that actually is going to delve into my file system and start digging into MSIs. And what I've done here is I've set a breakpoint, as you would do in Visual Studio, on one of the top level methods in this class. So here's what I prepared earlier. I've already got that command line that I had before, and so we're going to aim.exe, and we are debugging. We're going to run the migrate, and if I just execute this, we get a little prompt on our command line that we're going to attach the debugger to process 11344 brackets aim, because it's aim.exe that we're attaching to. So in Visual Studio, I'm sure you'll be familiar with this, because in BizTalk, if you want to debug into any classes that are being invoked by an orchestration, for example, you have to attach onto your BizTalk host instance and then debug into those assemblies. So BizTalk developers quite familiar with going to the debug menu and going to attach to process. And what we'll see at the top of the process is you've got aim.exe, The ID is 11344 in this case, and you just click attach to that. And then the tool will run, but we're actually debugging now. And there we go. So we've hit our breakpoint, and we're now going to debug into this in Visual Studio. So I've got access to everything that you don't normally expect debugging. So we've got all the different locals, and we can, we've got the context menu where we can see the value of all the things, and I can then step through the code and then go through and just see exactly what's happening line by line as I go through the code. And then what I'll do now is I'll just hit continue, and our command line will just go through. I said we're in verbose mode, so there we go, absolutely tons of debug trace going through. And then we get to the end of it, and we've successfully completed running through the tool. We've debugged it, and we've been able to step in to the actual code with a working instance of the tool. So that really is everything that I was going to take you through in this demo. And so hopefully that's helped you. So just to recap, we've talked about the hierarchy of the different repositories and how they interrelate. We've talked about getting all those forked and cloned in GitHub and onto your local machine, get them built, and then we've been able to debug onto those just using the debug switch of the command line. So hopefully that's been helpful to you. I'll now hand over to Dan, who's going to talk to you in a bit more detail about the stuff that goes behind the tool and how actually those bits of code and the templates interrelate to actually make the solution, which is what you need to do your changes.
Awesome. Thanks, Andrew. Alrighty, so I'm taking you through a number of different things really here. I realize I'm on the wrong slide now. So the insides of the tool in terms of the code, how it runs, that's what I'm going to talk a little bit about now. So exactly how the analysis and conversion works when it starts running through. And then we're going to also talk a little bit about how do you make changes. So Andrew's talked through, how you might debug it and things like that. But what if you want to write your own adapter, for example, or understand or contribute a bug fix or something like that? How does the tool actually do all that? So let's look first at how the conversion works. So in its present form, the tool is taking in an MSI. And the first thing it's going to do is extract that MSI. And in the MSI, you'll find the binding file and a number of BizTalk assemblies, plus any other assemblies you're referencing as well, if they're included. And that's the discover phase. So discovering what you have in your BizTalk application. Right. And what happens then is a number of rules run over that, the parsing rules, and they parse out the binding file, and they crack open the assemblies and look inside there. So look inside the orchestration definitions and the schema definitions and the map definitions. And it builds a source model. So the source model is describing what you have in your BizTalk estate. Yeah, and it's a JSON file. And then after that, there's going to be a target model built. And there's a series of analysis rules that run over the source model, looking at what they can find, and they add to the model in a separate section, and they output the target. So what is going to be generated in AIS, or whatever the Azure equivalent is going to be for on-prem, I guess. But the target model is what can be created using Azure resources, and that's a series of analysis rules. So, for example, there's an analysis rule that runs over the source model looking for FTP receive adapters or FTP receive locations. And there's one that looks for, HTTP receive locations, and one that looks for orchestrations and all the rest of the things that you'd expect to find in your BizTalk application. Following that, we end up with a report, and this is the reporting phase. So the report is generated from the source model and the target model. So the source model is what do we have at the moment, and the target model is what are we going to end up with. Then we have the report. And then the final phase is conversion. So conversion runs over the target model and generates the scripts and templates needed to create the Azure resources, logic apps and API management and all the rest of it. So end to end, that's what the tool does. One interesting thing is that you can export that model. So we talked about the target and source model. You can export that model using a -o option. So for example, if you run an assess, so this just generates the report, you can do a -O option here and supply a file name, and it will output a JSON file that has all the information that's found. So it's basically the information that's used to build the report and also build the output. I know we've had some of our clients ask questions like, well, how can I change the name of resources? And the answer is via this file. Because what you can do then is once you've looked at it and maybe made changes to it, you can then import it again. So you can run aim convert with a -M option or -M with the same model file, and it will run the tool as if it had run all the way through, but you've actually paused it in the middle, so you can make changes. So if I give you a little example here and show you what it looks like. This here, and I'm hoping this is quite a large file, but this is for the FTP scenario, and I've opened it up in 2 windows because it's so big. You know, there's 3,000 or 5,000 lines in this file. And on the left here, this is the source part. So it's describing everything it's found. So from the MSI and what's inside the MSI and all the assemblies. And at various points, you'll find reference to the receive location, the FTP receive location that's in this scenario. And in fact, if we go quickly switch over to the BizTalk admin console, and I appreciate this is very small, it's quite difficult to make it bigger. But in this scenario here, this is an FTP receive location using the FTP adapter. And we have a URI of 127.0.0.1 on port 21, and it's taking things from a folder called receive, and the file mask is star.star. So those are the parameters set, the configuration set for that receive location. If we come back out into the model here, you'll see that's what's in here. So it's pulled this out from the binding file and it's put this into the model. And if you went all the way down through here, you'll find lots of references to everything that's in your binding file. Obviously, if you have a very large application with hundreds of receive locations or orchestrations or something, this model file will be very big. Further down the file, you'll start seeing the target. And in the target, you'll start to see what's going to be output. So what is the system or the tool going to be outputting? So here we can see, for example, it's going to output an FTP receive adapter. And the name of the scenario, which is the unique set of config for this path through the tool, is the name of the application, the name of the receive port, and the name of the receive location. And it's an FTP receive adapter. And down here, it's got all the properties it's pulled from the binding file. Yeah. So this here is the target. So this is what is used to generate all the configuration and the templates and everything that are going to be output, ready to be deployed up into Azure. And you can modify this at this point here. So if you didn't like the name of something, you can come in here and find the name of the Azure resource in here and start changing them. And then when you run the tool again using the -M option, what it will do is it will use those names when it generates the templates. So that's one way that you can use of changing the names of resources that are going to be output. Okay, so that's the model. Right, if we come back to here, one of the things I wanted to talk about is that the process that is used to go from your MSI and the model all the way through to the resources at the end. So what's effectively happening is that in the beginning, we have an MSI and a series of rules that run over the MSI, and they build a model. And then what's going to happen is we have there's a YAML file, and I'll show you this in a moment. There's a YAML file that describes what is going to be built, and it's a liquid file. And if you're familiar with liquid templates from other work and using integration accounts and things like that in Azure, what it's doing is the liquid template is being executed, taking in the model as an input. And I'll show an example of this. So you'll end up then with a YAML file, which is the configuration. And then after that, that YAML file has pointers to all the Azure artifacts to be created. And a lot of those are liquid templates anyway. So what happens is for each of those, they're discovered, and then the liquid template or the liquid processor is executed with that input and with the parameters that are passed in from the config file here. This will become a lot clearer when I give you an example in a moment. But understanding this helps you understand how you can add to the system. Because effectively, if I wanted to add a new adapter, for example, I have to make sure it's being discovered and put into the model. And then I have to also make sure that there's a configuration entry for it in the YAML file. And then I have to make sure that there are templated artifacts for it here as well. Alrighty. So if we look at, say, the FTP receive adapter, let's have a look and see how this is put together. So the discover and parse stage runners are going to unpack the MSI and parse it and build that model. So there's an initial source model. It's got placeholders for the application and the receive port and the receive locations. And then for the FTP receive adapter, there is a rule or an analysis stage runner rule called RP001. And that's going to look for FTP receive locations in the source model. And it's going to add the details to the target model. And this is a bit of C# code. And then the values in that target model are going to map to values in that YAML file that's in the AIM BizTalk repo. And then that YAML file points to templates in the AIM Azure repo. It makes a lot more sense once you've been through it once. It took me a while to get my head around. I've been using it to try and build new adapters and make changes to existing adapters. So once you get your head around how it works, it kind of makes sense. And it keeps everything sort of separate as well. So let's go on to a demo. We're going to start with looking at, where shall we start? Let's look at the rule that runs first. So I'm going to look at that in Visual Studio. So in here, I've got the AIM BizTalk repo open, and I've got the a solution in here, which is the BizTalk solutions, the same one that I think Andrew had open earlier. And in the Analyze project, there's a folder called Conversion Rules, and in here, there's one for the FTP receive port. You'll see there's also one for file receive port and HTTP receive port. Okay, so the FTP receive port analyzer is in here, and these all follow a similar sort of pattern. And they start running through, and one of the things they start doing is they start parsing through the binding file and looking for FTP receive ports. So you can see here it finds all the receive ports in the application and then loops through all those receive ports and then loops through all the receive locations where the adapter is FTP. And then it's going to find the corresponding entry in the target model, because remember that it's created a placeholder for it already. And it's going to start inserting information in there. So one of the things it's going to do is it's setting this conversion rating here. So this is an enum, this conversion rating in here. And in there are a number of options, 0 to 5, full conversion, fidelity loss, partial conversion. If you've looked at the report, you'll notice that this matches the number of stars. And this is how the number of stars is worked out. So deciding what is supported is handled in this rule. So in this rule here, it's down here, it's saying that it can do full conversion, but not all properties are supported. That's what fidelity loss means. So not everything in BizTalk is supported in the FTP connector in Azure, yeah, but almost everything is. Hence full conversion with fidelity loss. What it will do down here then is it's going to map the adapter properties, and that goes to a bit of code further down. And it sets up all the properties that we need for the FTP connector in AIS. And then for each of those, it's going to find the corresponding value in the binding file. So server address is known as server address, that's fine. But some things are slightly different. So representation type is known as, in BizTalk, which is binary or ASCII, is known as binary transport in the FTP connector. So it's mapping those across. Yeah, it's working out what the values should be. So use SSL in BizTalk is SSL. And it adds those to the target model. So if I was to go and look in that target model now, I'd find these values being set. So now the rules run, and it's taken everything out of the binding file, and it's populated that into the target model. Now, if this was, say, an orchestration analyzer, so there's an orchestration analyzer here, that would be going through the ODX file that was extracted. All the ODX files would go through, and it would build a model of each of your orchestrations. So that's how all this works. Each rule is doing one specific task. Alrighty, so now we've done that, we've built that. Now we can have a look at the YAML file that drives things next. So I use Visual Studio Code for looking at the YAML files just because I prefer it, but you might use something else. in the AIM BizTalk repo, there's a folder called config, and in there is a number of YAML files for each of the things that are being output. And if we look at the BizTalk application here, which is the system application, the equivalent of the BizTalk.application in BizTalk, we have a big YAML file here, which is a liquid template. So what's happening is the liquid processor is being run, and it's being passed in the model that we just talked about. And there's a section in this YAML file for each supported resource. So we're in the section here for FTP. So FTP receive here. And what's happening here is it's looping through all the applications it finds in the model. And then if it's an adapter and it's FTP and it's accept, which is the exchange pattern for receive, then it's going to start looping through this section and output whatever's in here. In this case here, this is an API connection here. So it's going to generate the name of the resource. And then down here, it's pointing to the inputs. So remember we talked about in the AIM Azure repo are the actual templates that are used to generate, the logic apps and APIM and the API connections and everything. This is the reference to those. So it's saying if you're in the dev environment, then the path to the API connection template to use for the receive adapter is this file here, and it's a liquid file, which means that the liquid processor will run over that and will pass in these parameters to the liquid file. Yeah. And if we come further down here, we'll find the actual FTP adapter itself. So here's the FTP adapter, which is a logic app. So it's saying that it wants to run the liquid processing over the parameter file here. Now, you can see also here that there is a logic app, and then there is a dev parameters file or a prod parameters file, depending on whether you've run the tool using the dev or prod option. But the parameterization here is only handled in the parameter files. The logic app itself doesn't change. So no matter what it's parsed out of BizTalk, the logic app is going to be the same. So they've designed it such that the logic app is effectively like a cookie cutter. It's the same each time, and all that's changed is the parameters in the parameter file. So we now have references to a series of liquid files here. So once the liquid processes run over this, we're going to end up with a YAML file. And then there's another stage runner for conversion. And what that's going to do, if we go and look in the AIM Azure repo. So now I'm in the AIM Azure repo, and this has got a workspace, so it opens everything up in nicely. There's a templates folder in here, and then we've got endpoints. And if we look for FTP and receive, here are all those files that were referenced in that YAML file. So we'll find ones for the logic app here, and then the API connection. So the liquid file here for the logic app, if we look at this here, you'll see as a liquid file, it's got references to, resource template, resource name, or let's take the integration account name here. So resource template, parameters, Azure integration account name. Now, if I switch back to that other repo, to the YAML file, we should find in here a reference. Here we go, right here. So this is the parameters being passed to that liquid file, and they themselves have come from the model. So it's a two-part process, from the model to the YAML file, and the YAML file to the actual logic app parameter files. So that generates an output file, which will just be a parameters file without the liquid extension. And that's how it works. That it outputs all the files in this folder here. And what we've got going on in here is the all deployment. So a receive adapter, or an FTP receive adapter, is comprised of the logic app, the API connection that you use for connecting to the to your FTP location, and then there's also a service bus API connection as well. And then you've got the teardown deployment scripts that are all here as well. So the interesting thing is that when you install the tool using Chocolatey, these are all stored in a folder. I can't remember exactly. I think it's program data Chocolatey, something like that. But you can go and modify these if you want to. So you can just change them to suit whatever purpose you've got, and then when you run the tool, it will use those modified files. So if you just wanted to play with them and see what's going on, you can do that without having to necessarily commit your changes or anything like that. Alrighty, so that's all I was going to talk about. I think you can see that if you wanted to come in and add your own rules, it's fairly easy. So I'm working on a number of my own rules at the moment, which I'm hoping to add into the open source project for additional adapters and things like that. But that's how that works in here. You can add in additional rules here that will parse the binding file. Then you need to add an additional section into the YAML file that points to the template you're going to use, and then you'd have to add the templates that you want, the Azure templates, into the AIM Azure repo. All right, Valerie, that's me.
Excellent. Thank you very much. Really appreciate that. It's good content to start delving into the workings of the migration tool. If anybody has questions, please go ahead and you can put them in the chat window right now. And then we're also interested in getting input from you regarding what sort of information you'd like to have in the future on these webcasts. And specific questions are always welcome. Also, we do have the alias BizTalk Migration at Microsoft.com, and I'll type that. That's the email address for Migrator questions. There, I just posted that into the chat window for you as well. And if anybody out there has suggestions for what they'd like to have covered during one of these webcast sessions, please feel free to email that. That will send an email to me as well as John Fancy and Rebecca Lyons, so that if one of us is out at the time, somebody should be able to get back to you on that. And so if that's all we have, then this will be available for people to, as a recording for people to see later. And it'll be available up on YouTube within the next day or so. So thank you very much, everybody. And thank you so much, Dan and Andrew, for your time on this.
No problems. You're welcome. Thank you.
Right.
Okay.